Hey everyone, today we are going to solve the Daily LeetCode challenge of 30 March 2024 and the problem statement is subarrays with k different integers. So let us first understand the problem statement. So according to the problem statement, we have been given an integer array nums and an integer variable k. And what we have to do is we have to find out the total count of the subarrays that contains exactly k different integers. Okay. Now, before that, let us first understand what is a subarray. So a subarray is a continuous part of an array. That is, if I'll ask you that is this 2-1 a subarray? So you'll say that this 2-1 is a subarray because it is the continuous part of this nums and we are not missing any elements in between, right? Similarly, if I'll ask that is this 2-2 a subarray? So you'll say that this is not a subarray. Why? Because this is not a continuous part, right? Because we are missing an element in between. So this can't be considered as a subarray, okay? So now let's see that what is the count of the subarray that contains exactly two distinct integers for this given example. Okay. Before that, let us write down all the possible subarrays of this num. So we will have 1. After that, we'll have 1, 2. Then we'll have 1, 2, 1. Then we'll have 1, 2, 1, 2. And lastly, we'll have 1, 2, 1, 2, 3. Now we'll have this 2. Then we'll have 2, 1. Then we'll have 2, 1, 2. Then we'll have 2, 1, 2, 3. Now we'll have 1. We'll have 1, 2. We'll have 1, 2, 3. After that, we'll have 2, we'll have 2, 3, and we'll have this 3. Okay. So these are all the possible subarrays of this nums. Correct. So now let us write down the count of distinct elements present in each of these subarrays. Okay. So in this subarray, we can see that there is only one element. So the count of distinct element is 1. Correct. Here we can see we have a 1, we have a 2. So there are two different elements. Correct. Here we can see we have a 1, we have a 2. So we have two different elements. We have a 1, we have a 2, we have two different elements. Here we can see that we have a 1, we have a 2, and we have a 3. So in total, we have 3 different elements. Here we are having only one different elements, two different elements, two different elements. Here again, we are having 3 different elements because we have 1, 2, and 3. Here we are having only one different elements, two different elements, 3 different elements, 1, 2, and 1. Now what we want to find? We want to find the subarrays that have exactly k distinct elements, right? So are we going to consider the subarray? The answer is no. Why? It's because we want a subarray that contains exactly two different elements, right? So we won't consider this one. Are we going to consider this subarray? The answer is yes. Why? It's because it's containing two distinct elements, correct? Are we going to consider this subarray? The answer is yes, because it's containing two distinct elements. Are we going to consider this subarray? The answer is yes, because it's contained two distinct elements. Are we going to consider this subarray? The answer is no. Why? Because it's containing three distinct elements and we wanted only two, right? Are we going to consider this subarray? The answer is no, because it's containing one distinct element. Are we going to consider this subarray? The answer is yes, because it's containing two distinct elements. Now, are we going to consider this subarray? The answer is yes, because it's containing two distinct elements. Are we going to consider this subarray? The answer is no, because it's containing three distinct elements. Similarly, we won't consider this one, we will consider this one, we won't consider this one, we won't consider this one, we'll consider this one, and we won't consider this one. So which are the subarrays that we are left with? We are left with this one, this one, this one, this, and this one. And what we wanted to find? We wanted to find the count. So what is the count? The count is 1, 2, 3, 4, 5, 6, 7. So our answer to this problem would be 7. That is, we have total 7 subarrays that contains exactly k distinct elements. That is, 2 distinct elements, right? Now the question is, how are we going to solve this? But before that, I would like to ask you two questions. That is, give me the count of subarrays that contains at most k distinct element. Correct. Now, what does at most means? At most means less than or equal to k. Correct. And what is k in this case? In this case, k is 2. Correct. So what does it mean? It means less than equal to 2. So let us find out that what is the count of subarray that contains less than or equal to two distinct elements, correct? So in this subarray, how many distinct elements do we have? We have only one distinct element. So are we going to consider this? We are going to consider this. Why? Because we want the subarrays that has either two or less than two distinct elements, correct? So we will consider this one. We will consider this one as well. Why? It's because it's containing two distinct elements. We'll consider this one. Similarly, we'll consider this one. Now, are we going to consider this? The answer is no. Why? It's because it's containing three distinct elements. And what we wanted either two or less than two distinct elements, right? Now, are we going to consider this one? The answer is yes. Why? It's because it's containing only one distinct element, right? And what we wanted two or less than two distinct elements. So we will consider this one. Similarly, we'll consider this one. And we won't consider this one because it's containing three distinct elements, right? Which is not less than equal to 2. Similarly, we'll consider this one, we won't consider this one, we'll consider this, and we'll consider this. So what is the count? The total count is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in total, we are having 12 subarrays that contains at most 2 distinct elements, right? Now, let us find out the count of subarrays that contains at most k minus 1 distinct element. Okay, so since in our case the value of k was 2, so what would be k minus 1? K minus 1 would be 1. And what we want to find? We want to find the count of subarrays that contains either 1 or less than 1 distinct elements, correct? So let us find this out. So if we are at this subarray, so are we going to consider this? The answer is yes. Why? It's because it's containing 1 distinct element and it's satisfying this condition. That is, it should contain either 1 or less than 1 distinct element, correct? Now, are we going to consider this subarray? The answer is no. Why? It's because it's containing 2 distinct elements. And how many distinct elements we wanted? We wanted 1 or less than 1, right? Similarly, we won't consider this subarray. We won't consider this subarray. We won't consider this subarray. We will consider this subarray. Why? It's because it's containing only 1 distinct element and it's less than equal to 1, correct? Now, we won't consider this subarray because it's having 2 distinct elements and we wanted either 1 or less than 1 distinct element, right? Now, we won't consider this subarray as well. We won't consider this one. Now, we will consider this subarray because it's having only 1 distinct element. Similarly, we won't consider this one. We won't consider this one. We will consider this subarray because it's having only 1 distinct element. Now, we won't consider this one and we will consider this one because it's having only 1 distinct element and we wanted either 1 or less than 1 distinct element, right? So what is the count? The count is 1, 2, 3, 4, 5. That is, we have got 5 subarrays that contain at most 1 distinct element, correct? Now, if we will subtract this 5 from this 12, what we'll get? We'll get 7. And what's our answer? Our answer is also 7. So can we find a pattern over here? The answer is yes. So let me represent this over a number line. So if we have k over here and if we have k minus 1 over here. So what is k? In this case, k was 2. So what would be k minus 1? K minus 1 would be 1, correct? Now what does at most 2 means? At most 2 means it should have either 2 distinct elements or less than 2 distinct elements. So what is less than 2? In less than 2, we have only one possibility. That is, it should have either 1 distinct element or it should have 2 distinct elements, correct? So it means that if we consider at most k, we will have either 1 distinct element in our subarray or we will have 2 distinct elements in our subarray, correct? Now, if we will consider at most 1, so what does it mean? It means that it should have either 1 distinct element or less than 1. So in this case, we don't have anything for less than 1, right? So it means that we will have only these subarrays that contain 1 distinct element, correct? That is the subarray that will contain only 1 distinct element. Now, if we will subtract the count of this at most 1 from at most 2, what will happen? Their common part will be cancelled out. So what is the common part? The common part is this one, right? That is the subarrays that are containing only 1 distinct element, right? So this will get cancelled out. So what we will be left with? We'll be left with only the subarrays that are containing exactly k distinct elements, and in this case k is 2, correct? So we can see that we are left with only the subarrays that are having 2 distinct elements. Similarly, if we'll see over here that these are the common subarrays, right? These are the common subarrays. So if we remove this one, this one, this one, this one, this one. So which are we left with? We are left with this, and this. What is the count? The count is 7. And we can clearly see that what is the count of the distinct element? The count is 2. Here as well it's 2, 2, 2, 2, 2, 2. So it means that if we subtract them, their common part will get deducted. It will get cancelled out and we will be left with exactly k at most elements, right? So now that we have understood that how are we going to approach this problem, now the problem that lie is that how are we going to find the count of subarrays having at most k distinct elements, right? So let's see how we can do it. So what we discussed is, we will first find out the count of subarrays that contain at most k distinct elements. After that, we'll find out the count of subarray that contains at most k minus 1 distinct elements. And once we subtract them, we will get the count of subarrays that contains exactly k distinct elements, correct? So let's see how we can find out the count of subarrays that contains at most k distinct element, correct? Now, at most means either less than or equal to k distinct element. So say for example, if these are some of the elements of our subarrays, so what we will do is, we will keep on acquiring the elements of our subarrays until we are in a valid subarray. Now, what does a valid subarray means? A valid subarray means that until it's going to contain either k or less than k distinct element. because that's our case for a valid subarray, right? So until that time, we are going to acquire those elements. And the moment we'll hit an invalid subarray. Now, what is an invalid subarray? An invalid subarray is that subarray in which the count of the distinct element exceeds k. Okay, so the moment the count of the distinct element will exceed k, what we'll do is we'll try to make this subarray valid. And how are we going to do it? We will do it by shrinking this subarray until the point it doesn't become valid again. Correct? So what we are doing is we are expanding the subarray. That is, we are expanding this particular window until we have a valid case. And the moment we hit an invalid case, what we'll do is we will start shrinking. So this method is called the sliding window method. So we will be using the sliding window method in order to solve this problem. So let's see how we can do it. So we will make use of two pointers, release and current. So I am representing release with R and current with C. Okay. This count variable is being used to find out the count of the number of subarrays that's containing at most k distinct element, correct? And initially it would be 0. And we are using this distinct variable in order to keep track of what is the count of the distinct element that we have got up till now. Okay. So initially it would be 0 as well. Now we'll be using a hash map. Now, why are we going to use a hash map? So we will be using a hash map in order to keep track of whether a number is a distinct number or not. So say for example, if I am present at the number 1, so I'll check that is it present in hash map. If it is not present in hash map, then it means that it's a distinct element. So I'll simply increment the distinct count. And if it is already present in hash map, so it means that it's not a distinct element, right? Because it's already a part of our subarray. So in that case, we won't increment the distinct count. Okay. Now the moment we'll hit an invalid window, what will do? Okay. Now what is an invalid window? So whenever this distinct count will exceed k, it means that we are in an invalid window because we wanted the distinct elements to be either k or less than k. So whenever it will exceed k, so it means that we are in an invalid window. So what we will do is we'll try to make it valid. And how are we going to do that? We are going to do that by removing the element present at the release point. So say for example, if the name of our hash map is frequency, so what we will do is we will decrement the frequency of the element present at this release pointer. Okay. And if we'll find that the frequency of the element present at the release pointer becomes 0, then what does it mean? It means that we have removed an element from our subarray, correct? So if we have removed an element from our subarray, then what does it mean? It means that we have removed a distinct element. So we will simply decrement the distinct count at that moment, correct? And we'll simply increment the release pointer. So this is what we are going to do in order to make the invalid window as a valid window, correct? So let's quickly do a dry run in order to understand this in a better way. So currently our current pointer and release pointer both are at the 0th index. So what we will do, we'll check, is this 1 present in our hash map? So we can see that 1 is not present in our hash map. So what we will do, we will increment the distinct count because it indicates that this is a distinct element. And what we will do, we will add this 1 and its corresponding frequency to the hash map. Okay. And after that, what we will do, after that, we will add current minus release plus 1 to our count. Now, what is current? Current is 0. What is release? Release is 0 plus 1. So we'll add 1 to our count and we'll get 1. Now, what does this 1 represent? This 1 represents that we have got a subarray that contains at most 2 distinct elements. Okay. What does at most 2 means? At most 2 means either 2 distinct elements or less than 2 distinct elements. And which is that subarray? This is that subarray. Correct. We can clearly see that we have only one element in it. That is this one. And we are having only one distinct element. So we are in a valid subarray. Correct. Now what we will do? Now we will simply increment our current pointer. So our current pointer is at the 1th index. Now we'll check, is this 2 present in our hash map? So 2 is not present in our hash map. So it means that this is a distinct variable value. So we will increment the distinct count. So it will become 2. And what we will do now? We will add this 2 to our hash map. Now we will check, are we in a valid window? So we will check that what is our distinct count? Our distinct count is 2. So is our distinct count exceeding the value of k? So what is k? K is 2. So is this distinct count greater than 2? So it's not greater than 2. So it means we are still in a valid window. So what we'll do, we will add current minus release plus 1 to count. So current is 1, release is 0, plus 1 will get 2. So we will add 2 to our count and we'll get 3. Now what does this 2 represent? This 2 represent that we have got 2 subarrays that is containing 2 or less than 2 distinct elements. And what are those 2 subarray? It's this one and this subarray, that is 2 and 1, 2. Correct. Now what we will do? Now we will move our current pointer forward. Now we have got a 1. So we will check, is this 1 present in our hash map? So we can see that 1 is already present in our hash map. So it means that it's not a distinct element. So we won't increment the distinct count. And what we'll do, we'll simply increment the frequency of 1 in our hash map. And we'll check whether we are in a valid window or not. So what is the distinct count? Distinct count is 2. So is this 2 greater than 2? So 2 is not greater than 2. It means that we are still in a valid window. So what we'll do, we will add current minus release plus 1. That is, we'll add 3 to count. Now, what does this 3 represent? This 3 represents that we have got 3 subarrays that is containing either 2 or less than 2 distinct elements. And what are those 3 subarrays? It's this one, and this one. That is 1, 2, 1, 2, 1, and 1. Correct? Now, what we will do? Now, we will simply increment our current pointer. So, our current pointer will point at the third index. Now, we will check, is this 2 present in our hash map? So, we can see that 2 is already present in our hash map. It means that this is not a distinct value, right? So, we won't increment the distinct count. Now, what we will do? Now, we will check whether we are in a valid window or not, correct? So, we will check that is our distinct count greater than k. So, our distinct count is 2, and is 2 greater than 2? So, 2 is not greater than 2. It means we are still in a valid window. So, what we will do? We will add current minus release plus 1. That is, we will add 4 to our count. And what does this 4 represent? This 4 represent that we have got 4 subarrays that contains either 2 or less than 2 distinct elements. And what are those 4 subarrays? It's this one, that is 2, 1, 2, 2, 1, 2, and 1, 2, 1, 2. Correct? So these are the 4 subarrays that are having 2 or less than 2 distinct elements. Now what we will do? Now we will simply increment our current pointer forward. Now we'll check, is this 3 present in our hash map? So this 3 is not present in our hash map. So what does it mean? It means that this is a distinct element. So what we will do is, we will increment our distinct count and we will add this 3 to our hash map. So we'll get 3 and its corresponding frequency at 1. But before that, don't forget to increment the frequency of this 2, right? So it would be 2 over here, okay? Okay. Now what we will do? Now we'll check whether we are in a valid window or not. So we will check that what is the distinct count? Is 3. So is this 3 greater than 2? So 3 is greater than 2. So what does it mean? It means that we are in an invalid window. Additionally, you can also see that if this is our window, so how many distinct elements do we have? We have a 1, we have a 2, we have a 3. So we are having total 3 distinct elements. But how many distinct elements we wanted? We wanted either 2 distinct elements or less than 2. Correct? So since we are in an invalid window, what we will do? We will make it valid. And how are we going to do it? We will do it by releasing the element present at this release pointer. So what we will do is, the element present at the release pointer is 1. So we will decrement its frequency. So if we will decrement the frequency of 1, it would become 1. So we'll check, is it the frequency of the release element 0? So it's not 0. So what does it mean? It means that we won't decrement the distinct count. And what we will do? We will simply increment this release count. This release pointer is now at 2. Now what we will do, we will check that what is the distinct count. Distinct count is still 3 and 3 is greater than 2. So it means that we are still in an invalid window. So what we will do, we will decrement the frequency of this 2. So it will become 1. And we will check that is the frequency of 2 0. So it's not 0. Now what we'll do, we'll simply increment our release pointer. So our release pointer will now point at this 1. Now we'll check, is the distinct count greater than k? So our distinct count is still 3, which is greater than 2. So what we'll do, we will again decrement the frequency of 1. So the frequency of 1 will now become 0. Now we'll check, is the frequency of nums of r equal to 0? So we can see that the frequency of 1 has now become 0. So what does it mean? It means that we do not have 1 in our window anymore. Correct? So what we will do, we will simply decrement the distinct count. So our distinct count will now become 2. And we have incremented the release pointer. Okay, so it means that our release pointer is over here. Additionally, you can see that in this window, we don't have 1, right? We are having only 2 and 3. And these are the only 2 distinct elements. And our distinct count is also 2. So now what we will do is, now since we are in a valid window, because our distinct count is not greater than 2, it means that we are still in a valid window. So what we will do, we will add current minus release plus 1. So our current is 4. Release it at 3 plus 1. We will get 2. So we will add 2 over here. And what does this 2 represent? This 2 represent that we have got 2 subarrays that are having either less than or equal to 2 distinct elements. And what are those 2 subarrays? It's this one and this one. Correct? Now what we'll do, we will increment our current pointer. So our current pointer is now pointing at the end of nums. So what does it mean? It means that we have successfully processed all the elements and we have got the count of the subarrays that is containing at most k element. And what is the count? It's 3 plus 3 plus 4 plus 2. That is 12. Correct? So what we got the count of subarray that contains at most k distinct element. We got this count as 12. Correct? Now let's follow the same approach in order to find out the count of subarray that contains at most k minus 1 distinct element. Now what we want to find? We want to find the count of subarrays that contain at most k minus 1 distinct element. So what is k? K is 2. So what would be k minus 1? K minus 1 would be 1, correct? So now what is this k? The k is 1, correct? That is, now we want only one distinct element. That is, the count of distinct element should be either 1 or less than 1, correct? So let's start the dry run. So we are present at this 1. We'll check, is this 1 present in our hash map? It's not present in our hash map. So what does it mean? It means this is a distinct element. So we will increment the count of distinct element and we will add this 1 to our hash map. Now we'll check, is it a valid window? So what is the count of distinct element? It's 1. So we'll check, is this 1 greater than 1? So 1 is not greater than 1. So what does it mean? It means we are in a valid window. So what we'll do is, we will add current minus release plus 1 to our count. That is, we'll add 1. What does this one represent? This one represents that we have successfully got a subarray that is having 1 or less than 1 distinct element, and this is that subarray, correct? Now what we will do? Now we'll simply increment our current pointer. So our current pointer is now pointing at 2. Now we'll check, is this 2 present in our hash map? So 2 is not present in our hash map. So what we'll do? We will add it to our hash map. And since it was not present in our hash map, so it means it's a distinct element. So we will increment the distinct count. So our distinct count will become 2. Now we'll check whether we are in a valid window or not. So our distinct count is 2. So is this 2 greater than 1? So 2 is greater than 1. So what does it mean? It means we are in an invalid window. Additionally, you can see that if this is the window, that how many distinct elements we are having? We are having a 1 and we are having a 2. That is, we are having 2 distinct elements. And how many distinct elements do we wanted? We wanted 1 or less than 1 distinct element, right? So since we are in an invalid window, what we will do is we will try to make it valid. And how are we going to make it valid? We are going to make it valid by removing the element present at the release pointer, correct? So the element present at our release pointer is 1. So what we will do is we will decrement its frequency. So its frequency will become 0. And we will check that is the frequency of the element of release pointer has become 0. So we can see that the frequency of 1 has become 0. So what does it imply? It implies that we have successfully removed an element from our subarray. That is, we have removed the distinct element. So what we'll do is we will decrement this distinct count. So it will become 1. And we will increment the release pointer. Additionally, you can see that this is our current subarray, and in the current subarray, we have only one distinct element, correct? So since we are in a valid window, what we will do is we will find out current minus release plus 1. So what we will get? We will get 1 and we will add it to our count. And we can also see that this 1 represents that we have got only one subarray that is having either equal or less than 1 distinct element, correct? Now what we will do? Now we will simply increment this current pointer. So this current pointer is now pointing at the element 1. Now what we will do? Now we'll check that is this 1 present in our hash map? So 1 is not present in our hash map, correct? Because we can see that the frequency of 1 is 0. So it implies that 1 is not present in our hash map, correct? So what we will do is, since it's not present in the hash map, it means that it's a distinct element. So we will increment the distinct count and we will add this 1 to our hash map. So its frequency will now become 1, correct? Now we will check whether we are in a valid window or not. So what is distinct count? Distinct count is 2. So is this 2 greater than 1? So 2 is greater than 1. So what does it mean? It means we are in an invalid window and we have to make the window valid now. Okay. So what we will do? We will decrement the frequency of the element present at the release pointer. That is, we'll decrement the frequency of 2. So it will become 0. Now we'll check that is the frequency of 2 0. So we can see that the frequency of 2 is 0. So what does it mean? It means that we have successfully removed the distinct element from our current subarray. So we will decrement the frequency of distinct. So it will become 1. And what we will do is we will increment our release pointer, correct? Now we'll check that our distinct count is 1 and 1 is not greater than 1, correct? So it means that we are in a valid window, and since we are in a valid window, what we'll do is we will add current minus release plus 1. So you can see that current is 2 and release is also 2, correct? So we'll say that current minus release plus 1 will give us 1. So we will add 1 to our count. And what does this 1 represent? This 1 represents that we have got a subarray that contains either 1 or less than 1 distinct element, and this is that subarray, correct? Now what we will do? Now we'll simply increment our current pointer. So our current pointer is pointing at the third index and we have 2 over here. So we'll check, is this 2 present in our hash map? So we can clearly see that the frequency of 2 is 0. So it implies that 2 is not present in our hash map. So since 2 is not present in our hash map, it means that it's a distinct element. So what we'll do is we will increment its frequency and we will add it to the hash map. Now we will check whether we are in a valid window or not. So the count of distinct element is 2. So we'll check, is this 2 greater than 1? So 2 is greater than 1. It means we are in an invalid window. So we have to make this window valid. And what we'll do? we will decrement the frequency of element present at release pointer. That is, we'll decrement the frequency of 1, so it will become 0. And since the frequency of 1 has become 0, so it implies that we have successfully released this 1 from our current subarray. So since we have removed the distinct element, so we will decrement the distinct count, so it will become 1. And we will increment the release pointer. Now we'll check, is our distinct count greater than 1? So it's not greater than 1. So it means we are in a valid window. So what we'll do is we will add current minus release plus 1 to our count. That is, we will add 1 to our count. And what does this one represent? It represents that we have got a subarray, which is this one, that has either 1 or less than 1 distinct element, correct? Now what we'll do, we'll increment our current pointer. So our current pointer is present at the 4th index and the element is 3. Now we'll check, is this 3 present in our hash map? So 3 is not present in our hash map. So what does it mean? It means that this 3 is a distinct element. So what we'll do, we'll simply increment the distinct count. And since it was not present in the hash map, we will add it to the hash map. Okay. Now we'll check whether we are in a valid window or not. So the distinct count is 2 and 2 is greater than 1. So it means we are in an invalid window and we want to make it valid. How we will make it valid? We will decrement the frequency of this 2, correct? So what we will get? The frequency of 2 will become 0. And since the frequency of 2 has become 0, so what does it imply? It implies that we have successfully removed the distinct element from our subarray. So we will decrement the distinct count. So it will become 1 and we will increment the release pointer, correct? Now we will check that is our distinct count greater than 1? So it's not greater than 1. So what does it mean? It means that we are in a valid window. So what we'll do? We will add current minus release plus 1, correct? That is, we will add 1 to our count. And what does this 1 represent? It represents that we have got a subarray that contains either 1 or less than 1 distinct element, and this is that subarray, correct? Now what we'll do, now we'll increment the current pointer. Now we can see that we have processed all the elements of this nums. So it means that we have found out the count of subarrays that contains at most 1 distinct element, correct? And what is the count? The count is 5, correct? So what we got the count of subarrays with at most k distinct elements as 5. Now what we want to do, we want to subtract this 12 and 5 to get the count of subarrays that contain exact distinct elements, correct? So what we'll get after subtracting 12 and 5, we will get 7, which is the answer, correct? Now I hope it is clear to you all. So let's quickly code this. So since we are finding out the count of subarrays that is containing at most k distinct element and that is containing at most k minus 1 distinct element. So it means that we are following the same approach 2 times, right? Firstly to find at most k distinct element and secondly to find at most k minus 1 distinct element. So what we can do is we can write a separate function. Let's call it at most k distinct, and what we will pass on the nums array and we will pass on k, correct? Now what we need a variable count that will keep track of the count of the number of subarrays that is containing this at most k distinct element, correct? We also need a variable distinct to keep track of the count of the distinct number we have till now, correct? We also need a release pointer, which would be initially at the 0th index, and we also need to create an unordered map. And why are we using this unordered map? We are using this unordered map to keep track of that whether an element is distinct or not. So what we'll store in it? We'll store the element and its corresponding frequency. Okay. Now what we will do is we will iterate over the given array. So we'll say current equals to 0, current less than nums dot size, current plus plus. Now, first of all, what we were checking? We were checking whether an element is present in our hash map or not. So let's say that this is the current value and the current value is nums of current, correct? So we'll say if frequency of current value is not 0, correct? So what does it mean? It means that it's present in the hash map. But what we want that if the frequency of current value is 0. So what does it mean? It means that it is a distinct value, correct? Because it's not present in our hash map. So in that case, what we will do, since it's a distinct value, we will increment the distinct count, correct? Now, after incrementing the distinct count, what we have to do, we have to add it to the hash map. So we will say that frequency of current val plus plus, correct? Now what we have to do is we have to check for the invalid window, correct? When a window is invalid, when this distinct count exceeds k, correct? So if it will exceed k, what we will do? We will try to make it valid by releasing the element present at the release pointer, correct? Now after that, what we have to check? We have to check that if the frequency of the element present at the release pointer is 0 or not. If it is 0, then what does it mean? It means that we have successfully removed the distinct element from the hash map. So we will decrement the distinct count and we'll simply increment the release pointer, correct? Now the moment will come out of this while loop, or if we will not go inside this while loop, so what does it mean? It means that we are in a valid window. So since we are in a valid window, what we will do is we will add current minus release plus 1 to this count, correct? And finally we will return count. Fine. Now what we wanted to do over here, we will say that return, and we will call this function at most k distinct to find out the count of the distinct element for at most k distinct element, and we will subtract the count of at most k minus 1 distinct element, correct, to get the answer. So let's quickly run this. So it's giving us the correct answer. Let's submit it. And it got accepted. Now talking about the time complexity and space complexity, if we consider n as the size of the given array nums, then the time complexity would be order of n. Why? Because we can see in this function that what we are doing. We are iterating over the entire array nums in order to find out the count of the subarray that's containing at most k distinct element, right? Now, since we are iterating over all the n elements, so it is going to cost us a time complexity of order of n. Now we are calling this function 2 times. First, to find out the count of subarray containing at most k elements, and secondly to count the subarrays that is containing at most k minus 1 elements, correct? So it means that we'll be iterating over the given array twice. It means that we are taking a time complexity of order of 2n, and since 2 is the constant, so we can ignore it. So our ultimately time complexity would be order of n only. And since we are using a hash map, so our space complexity would be order of n. Okay, so that's all about today's daily LeetCode challenge. Thank you.